So in this video we'll be solving the questions from exercise 1.3 of chapter sets. First question is, we have to make correct statements by filling in the symbol subset or not subset in the blank. So question 1, set with 2, 3 and 4, and we have another set 1, 2, 3, 4 and 5. Here 2, 3 and 4 are present in the second set, 2 here. So we can say that this is a subset of set B. So then coming to the second question, we have A, B, C, and in the other set we have B, C, D. So we see that A is missing in this set, so this is not a subset of the other set. Coming to the third question, so X is a student of class 11 of your school and X is a student of your school. So X is a student of from class 7, so any student from class 7 is a student of the school as well. So from this we can say that first set is a subset of the second set. So the fourth question is, X is a circle on the plane and the other set is X is a circle in the same plane with radius 1 unit. So here we can tell this is not a subset because the first set X is a circle in the plane. So X, the radius of that circle can be anything, 1 unit, 0.5 unit, 100 units, 1000 units, anything. But in second set we have circles which have radius only 1. So the first set, all the terms are not present in the second set, so it is not a subset. The fifth question, X is a triangle in the plane and X is a rectangle in the plane. Again, this is not a subset because triangles are not same as rectangles, so that's why it's not a subset. So coming to the sixth question, so first set is X is an equilateral triangle in the plane and the second set is X is a triangle in the same plane. So we know that all equilateral triangles are triangles. So from this we can say that the first set is a subset of the second set. And coming to the seventh question, X is an even natural number and X is an integer. So we know that all natural numbers are a subset of integers Z. So we can say that, and the first set is an subset of the second set. So coming to the second question, examine whether the following statements are true or false. So we have first set A, B, which is not a subset of the second set B, C and A. We see that A and B are a part of the second set, so it is a subset, so it is false. The second question, the first set is A, E and the second is vowels in the English alphabet. So we know that vowels of English alphabet are A, E, I, O, U. So first set is a subset of the second set, so the statement is true. So the third question is set with 1, 2 and 3 and the second set is 1, 3 and 5. So we see that 2 is missing in the second set, so first set is not a subset of the second set, so the answer is false. So the fourth question is set with the letter A, and in the second set we see that we have A, B and C in the second set. So so the first set is a subset of the second set, so it is true. The fifth question, we have again the same sets, letter A in the first set and letters A, B, C in the second set. The first letter A is a subset of B, but they've used the symbol belongs to in the equation there, so this is not the right symbol to be used there, so the statement is false. We can't have two sets belonging to one another. So the sixth question, X is an even natural number less than 6 and X is a natural number which divides 36. So even natural numbers less than 6 are 2 and 4. So this is the first set, and the second set are natural numbers which divides 36. So numbers which divide 36 are 1, 2, 3, 4, 6, 9, 12 and 36. So we see that 2 and 4 are present in this, so the first set is a subset of the second set. Third question, So we have let set A is equal to 1, 2, 3, 4, 5. Which of the following statements are incorrect and why? So we have been given that set A is equal to 1, 2, and we have another set 3, 4, which is a part of set A as well, and 5. So the first statement is 3, 4 is a subset of A. This is false because 3 and 4 are part of set A. So it should be written that 3 and 4 belongs to A, but we have given that 3 and 4 are a subset of A. So the first statement is false. So the second statement is 3, 4 belongs to set A. So from the previous question we know that this is true. So this statement is true. The third question is we have a double bracket here. 3, 4 a set belongs to A. So now this is a true statement. Why is this true? Because we have 3 and 4 in this bracket is just telling 3 and 4 are numbers, but when we put the second bracket outside, it tells that this is a set. So this set is a subset of A. So that is why this is true. But here we had only one bracket telling that 3 and 4 are only numbers and it is not a set. So that is why this was false, but this is true. So the fourth statement is 1 belongs to A. We know that 1 is a part of set A. So this is a true statement. Question 5 is 1 is a subset of A. We know that 1 is just a number which is in A, but 1 is not a set in itself. So since 1 is not a set, it cannot be subset of A, and this is a false statement. Statement 6 is 1, 2, 5 subset of A. So this is a true statement. So another set we can take this as set B, which has 1, 2 and 5. So we have 1, 2, 5 present in set A. So set B is a subset of A. So it is a true statement. So we have question 7 where 1, 2, 3. So the next question is 1, 2, 5 belongs to A. So we see that 1 to 5 is a set, and a set can only be a subset of another set. Set cannot belong to another set. So since this symbol cannot be used here, so this is a false statement. So the eighth question is 1, 2, 3 set 1, 2, 3 is a subset of A. This is a false statement because we see that 3 is within a bracket. In previous example we saw that we need whenever a number is inside a bracket, we need 2 brackets to make it a set, but 3 here is only between one set of brackets. So this statement is false for this example. So the ninth statement is a null set belonging to A. Again, like previously told, a set cannot belong to A. So this is again a false statement. 10th is null set is a subset of A. We had learned that every null set is a subset of all sets. So this is a true statement, since null set is a subset of set A. And last statement, set with null set is a subset of A. Null set is already a set. We need not put brackets here for this. So this representation itself is wrong. So this is a false statement. So next question 4. Write down all the subsets of the following set. So the first set is set A. So the first subset is null set. Then since you have only one letter, so these are the two subsets of set A. So the second set is brackets A comma B. So again null set. So we have the first term A, then B, then A comma B. Then we have the third question, 1, 2, 3. So again the subsets are null set 1, 2, 3, 1 comma 2, 2 comma 3, 3 comma 1, 1 comma 2 comma 3. Set question 4 is null set. So the only set which is subset of null set is null set. So coming to question 5, how many elements in power set of A if A is equal to null set? So it has been given that A is a null set and we have to find number of elements in in power set of A. So number of elements in power set of A is equal to 2 power m, where m is the number of terms. So in null set we know that there are no terms in the set. So from this we can get to know m is equal to 0 is equal to 2 power 0, which is 1. So p power a has only one element. So coming to the sixth question, write the following as intervals. So the first question is where x belongs to r is a real number between -4 and 6. So from this we can get to know first. So we'll take the set a is equal to -4, 6 square bracket. So we use -4, we use small bracket here because -4 is less than x. We don't have an equal to sign here, but we have a equal to sign for 6. So we have x is less than or equal to 6, so that's why we used square bracket. So for the second question, x is greater than -12 and less than or equal to 10. So from this we can get to know b is in the interval -12, 10 square bracket. So we have square bracket here for this and a round bracket here for -12. Third question, we have x is greater than or equal to 0 or less than 7. So the interval will be square bracket 0, 7. And fourth question, 3 is greater than or equal to x and less than or equal to 4. So since both 3 and 4 are is equal to x, so we have 3, 4 in square brackets. Coming to the seventh question, write the following intervals in set builder form. So we have to write the following terms in set builder form. So the first question is -3, 0. So we can write x belongs to r, and since we have round brackets here, -3 is less than x and x is less than 0. So the second question is 6, 12 in square brackets. So we have x where x belongs to r and 6 greater than or equal to x, less than or equal to 12. So used greater than or equal to here for both numbers since we have square brackets. So the next question is 6, 12 and we have x where x belongs to real number and 6 is just less than x because we don't have square bracket here, and then we have greater than or equal to 12 because you have square bracket here. And fourth question, we have -23, 5. So again, x where x is a real number, -23 greater than or equal to x, less than 5. So use equal here because you have a square bracket on your -23. So use less than or equal to x. Coming to the eighth question, what universal sets would you propose for each of the following? The first set is set of all right triangles. So we know that the right triangle, one angle is 90° and the other two angles are less than 90°, but we do not know the angle. So this cannot be an acute angle triangle, or this cannot be an acute angle triangle or isosceles. It can be isosceles, but all right triangles are not isosceles. So these two cannot be a universal set. It cannot be equilateral triangle also because all three angles are different. So the only universal set is set of all scalene triangles. Here the angle can be 90° for the scalene triangle, and it can accommodate all the different right triangles. So in the second question, set of all isosceles triangles. So we know that in isosceles triangle, two sides are equal, two angles are equal, and the third side and third angle are different. So again, for this, the universal set will be scalene triangle, since all isosceles triangles are scalene triangles. So coming to the final ninth question, given sets A is equal to 1, 3, 5, B is equal to 2, 4 and 6, and C is equal to 0, 2, 4, 6 and 8. Which of the following may be considered as universal set for the sets for all the three sets A, B, C? So we have to see which can be taken as universal set. So the first set is 0, 1, 2, 3, 4, 5 and 6. So we have all the terms from set A, 1, 3 and 5, We have all the sets from set B, 2, 4 and 6, but we don't have all the terms from set C. We have 2, 4, 6, but we don't have 8, so this cannot be a universal set, so answer is no. Second question is null set. So null set can be universal set only for another null set, so again this is no. So the third set is natural numbers from 0, 1, 2 all the way till 10. So in this we see that all the terms from set A are present, which is 1, 3 and 5, and again all the numbers from set B are present, which is 2, 4 and 6, and all the numbers from set C are present, which is 0, 2, 4, 6 and 8. So this can be a universal set. So coming to the set 4, which has 1, 2, 3, 4, 5, 6, 7 and 8. So we have all the terms from set A, 1, 3 and 5. We have all the terms from set B, 2, 4 and 6, but we don't have all terms from set C. We have 2, 4, 6 and 8, but 0 is missing, so this cannot be a universal set. So this is all for exercise 1.3.